like it's making sure that the envelope stuff here works, so you can actually, it's just like multiplying the deformation of every single point with this envelope attribute, so you can just tweak it easily like that. And with this one too, they're all working together like that. Grow, shrink, that's a pretty cool feature, to grow and shrink. So if you go in here, you can just grow the whole tension, so it's happening everywhere, or it's not happening. That was a bit tricky to code, actually. All the code for that is here. Okay, post smooth. Tension and angle fall off. So here, this is where we're actually doing the deformation, because we kind of like did all the calculation before. Like you build all the matrix, you do all the calculation for all these different things, and then you go, okay, now each vertex, where does it move? Again with OpenMP, so it's parallel. All the TU and TV is like the UV direction. Here's some angle stuff. The T is for tension here. Here you multiply all, when you get all these results, put it in the verts, variable, and you multiply it by the scale factor. This guy here, scale factor. So this one is going to work when you actually like scale your rig and you want a deformation to work accordingly. You just connect the scale attribute into the scale factor here, and it's just scaling your deformation. Okay. And basically it's doing all these calculations on how it has to deform and putting the result in the verts here, which we're gonna actually use later on to actually really do the transformation. Here's some stuff for the wrapping. This little section in here, because it has to, all the shapes, the different shapes that you hook into it, these ones, actually they're being like wrapped around the deformation of the original mesh as the original mesh is deforming. So you have to, all of these has to be wrapped into the original one. So when it triggers them, I mean when it like triggered the shrinking deformation here, if this one, like this point, is kind of internally, it looks like something like this, because it's just being wrapped around the other one. So as it's shrinking in this part, it's shrinking like in as if like these guys were like in here. Otherwise it would shrink to the center of the scene. So that's why we have some wrapping, which was pretty much a pain to figure out how to do. Applying the wrap here. This is for relaxing the vertex. That's pretty easy to do and very, very convenient feature. It's not the same as smoothing. Like smoothing is really like you have the tension and you just smooth the tension over. But it's always like smoothing, the tension is just saying like, okay, this part is going to be the original mesh, and this part is going to be the tension mesh or the angle mesh or whatever mesh. And the tension is just really like see it as like a mask of saying like, this is this, the other part is this. It's just a mask, and you're smoothing out the mask that you're using to blend between one or the other. As the relax is really taking the actual vertex And if you're going into like, well, not smooth here, but there's a relax actually. Somewhere in there. Average vertex. So it's doing pretty much the same as this. Average. So this is actually really gonna, like, if you have some hard edges on your geo, it's really gonna kill them. As if you just smooth the tension, it won't kill them, it will preserve them, and it will just transition from one shape to the other. So, again, this one works pretty much as like the same idea. You take your vertex and you check the neighbor, and you actually check the position in space of the neighbor, and you average out that position. Draw color per vertex. So all that part here, can have it for angle, for tension. All this part is happening here. Okay, so here that's a bunch of array that we just used to do all the computation. That's being deleted at this point because we don't need them anymore, and they're being these ones are being recreated every time it computes. Okay, now this thing here actually moves for real all the vertex to the position that we store into the verts variable. So all the part before do all its computation and stuff, store that in the verts, and now at this line we just apply that to the geo. Here, set clean. So basically there's Maya working with that system of like when a node needs to be computed, it set it dirty, and then when the computation is done, you set it clean. So that means it doesn't need to be computed again. That's some stuff I use here, and yeah. So that's pretty much it for the compute part, which is the biggest thing here. Okay, for initialize, got all that stuff here. If you look again in an example of whatever plugin in the dev kit, you'll find like this sort of thing, like the constructor creator, whatever. That's the class destructor here. So I believe that's when you unload it, or when you, no, I think that's when you actually delete a node. So it gets rid, I'm killing like all the matrix that were stored and that are not deleted during the compute processing, during the compute function, sorry. And the ones that we keep all the times, they're being destroyed at that time if you kill the node, so they don't stay in memory. And that's the arrays that are being destroyed as well. Okay. The initialize function here. So that's creating all the attributes, all these guys here on the node. A lot of attributes. All the wrap attributes, color attributes. Okay, here this is just saying the dependency, like whenever you move one attribute, what does it affect? Does it affect like another attribute or something? So pretty much all the attributes, what do they affect? They affect the output geom. So when you move an attribute, the geometry has to be updated. That's what it's saying. So it's like when this attribute gets updated, the geo has to be updated.